Namaskar Mitranno. Today we are going to see series resonance. Now what is resonance? Resonance is a particular condition. At that point we are extracting the maximum output from the given circuit. Okay, so now for RLC series circuit we are having R, L and C. The voltage drop across resistance is VR, voltage drop across inductor is VL and voltage drop across capacitor is VC. The current flowing is I. Voltage and frequency. Frequency is variable frequency we are assuming here. Now we know that inductive reactance XL is equal to 2 pi FL. That means it is directly proportional to the frequency. And XC is inversely proportional to frequency. If we plot the graph of frequency and XC, what we will get? XL is getting increase along with the frequency, while XC decreases along the frequency. Means at lowest frequency your XC will be maximum and at highest frequency your XL will be maximum. But at a frequency we are getting the condition that XL becomes exactly equal to XC. So that condition is called as a resonance condition. If XL becomes equal to XC, the voltage drop across inductor and capacitor also becomes equal, and the effective voltage of the circuit we will get as only across the resistance. What happens here? See, through this phasor diagram we will come to know if VR is along x-axis, upward is VL and downward is VC. This VL and VC will cancel out each other, and therefore the net voltage or the resultant voltage, which is nothing but total voltage which is we have applied V, is exactly becomes equal to resistive voltage, and the current which is flowing will be in phase with that resistance. Okay, and therefore the circuit behaves like a pure resistive circuit, or your phi or phase difference between V and I becomes 0. Therefore power factor becomes 1 and the power becomes VI cos phi, V that is equal to V into I, and that power extracted will be the maximum from the circuit. Okay, so that is nothing but the resonance condition. Now we will derive the expression for resonating frequency. So resonance frequency कधी मिळते आपल्याला? When XL becomes equal to XC. And what is XL? 2 pi FRL. At resonance frequency we are assuming FR. Okay, so 2 pi FRL is equal to 1 upon 2 pi FRC. If I take FR here and 2 pi here and solving it and arranging the terms properly, I will get FR is equal to 1 upon 2 pi under root LC into Hertz. And if you take this 2 pi with this FR, we will get omega equal to 1 by root LC, that is radians per second. So that is the simple expression for resonance frequency. Now what is the impedance at this resonance frequency? So we know the formula for impedance. Z is equal to under root of R square plus XL minus XC square. Now as this XL is equal to XC, this part will become 0, and therefore ZR is equal to root of R square, and ZR is equal to R. Now what is current at resonance? IR is equal to V by ZR, but ZR is equal to R, therefore it is equal to V by R. You can see here total voltage divided by resistance only. Okay, so that's why the current will be maximum at resonance frequency. This curve of I versus frequency, if you plot, what you will get? The current at resonance frequency will be maximum, and this curve is called as a resonance curve. Okay, now what is quality factor? Quality factor or Q factor is nothing but the ratio of voltage drop across inductor or capacitor, both are same, divided by the total supplied voltage. Okay, so it is nothing but VL or VC by V. So what is VL? We will take only VL, IR into XL, and what is V? It is IR into R. Okay, so XL by R, this IR will get cancelled, but what is XL? It is 2 pi FRL, and therefore if I rearrange the term 2 pi L by R, and instead of FR we will put the formula for that 1 upon 2 pi under root LC. Finally I will get Q factor as 1 by R under root of LC. Now bandwidth. Bandwidth is a frequency range for which current is either 70.7% or more than it. Okay, with respect to I current at resonance, and its formula is given by bandwidth is equal to R by 2 pi L in hertz or R by L radians per second. So here if I draw the line for 70.7% of IR, I will get 2 times crossover with the curve. So first crossover is the lowest frequency FL and the second crossover is FH, that is higher frequency, higher cutoff frequency, lower cutoff frequency, and therefore it is FH minus FL, or you can say WH minus WL. Now voltage drop across each element at resonance. So across resistance VR is equal to IR into R. But what is IR? V by R. So R will get cancelled. We will get supply voltage is equal to resistive voltage drop. VL is equal to IR into XL. IR into 2 pi FRL. But what is IR? V by R. And what is FR? 1 upon 2 pi under root LC. So if I rearrange the terms, I will get VL is equal to V by R under root of LC. Similarly, VC also we will get V by R under root L by C. So VC. So that is all about series resonance. The numericals are not expected in this syllabus. Thank you.